Showcase today how to calculate the final speed of a given object. Let's suppose object x, y, z, whatever. So you have a graph of force against distance. So how are you going to calculate the speed or velocity out from the given graph? And that's what I'm exactly going to show you guys in this video. So now remember that the work actually is force into distance, right? That means that if you take the area of this graph, that will give you the work done by the object in the first 10 meters, as this graph shows, because xf is the final position of the object and xi is the initial position of the object, is 0 meter. Well, once I apply that, now we know that the change in kinetic energy or any energy, in this case it's moving due to the velocity. So it will be change in kinetic energy, and this little triangle delta shows change in kinetic energy is equals to work done, which is force into distance. So first step, calculate the area of under all the objects, which will say that so as you can see in this video, that if I take the area of the triangle, it will give me half into base, which is 2, and then the height, which is 4, and then there are two such identical triangles, which will in fact, if you multiply it by 2, you will get the area of these two triangles. And then this rectangle, as the calibration of the graph is 1 2 3 4, so this is 1 multiplied by 4, so you add that, so 1 into 4, and then you plus that again. This little triangle, this is 1 into 2, and you divide it by half or multiply it by half, so it will be half into 2 into 1. And again, there are two identical in this part, so this area of the small triangle multiplied by 2, and remember that this is minus 2, so I have to take that into consideration. Now finally, this rectangle from 6 to 9 is the uh, breadth, as you can see, the height and the length. So minus 2 into 3, so I can just set that as minus 2 into 3, and now this all will give me the work done by the object. So if I calculate that, 2 goes against 2, so 8 plus 4. Again, now remember that 2 go against 2, so minus 1 into 2 will give you minus 2, as you multiply by this 2 outside the bracket, and minus 6. 2 into 3 is minus 6. So 8 plus 4 is 12. 12 minus 8 gives you 4 joule. Now joule is the SI unit for the energy. Now remember, we have to stick to what we had to find, and that was the velocity, right? So half mv square is the formula for the kinetic energy, and as the initial speed, we take it to be 0 meters per second. So what happens is that the change will be equal to Vf minus Vi, and after that you can say that this is how it stands. So this is 0, so this gets eliminated. So you're going to only take the final velocity, which we have to find. So I put that in this scenario now. The work done is 4 joule, and that equals to half mv square. So half m. Now mass, let's say it's 0.5 kg of the object. So what happens is you put that value here, and then multiply it by VF square, which we have to find, which is the unknown. Remember that is equals to the work done. So following this scenario, 4 joule. Now rearranging the formula and making VF the subject, what happens is that VF is equals to 2 goes up here, so 8, and then this half, could have actually, just half if you write it as a fraction. Or now, since I've written it as decimal, so I'll continue to use that scenario. So 8 divided by zero point 0.5. And that's all about the calculation part. We're done here. And by, pulling out your calculator and putting this value, you get 4 meter per second. So this was a clear demonstration of how to find velocity from a force distance diagram and the relations between the work done by the object and kinetic energy of an object. This was all about the day, guys. And for more videos, stay tuned and like the video if you found it informative. Subscribe to my channel and support free education.